Okay, good morning, everybody. Yeah, Doug, sorry. The arrival of the pandemic has really caused a lot of people to examine how work is being done. And if you remember, for our particular organization, they had to do a lot of work really quickly in order to beef up all of our remote access capability. I don't know if you know that much about the architecture, but they had, at one point, they had 4 different entry points for the VPN, and they've combined that all down to 1 with a backup. So they started off saying it's helpful to be everywhere, and then they said, well, no, it's really expensive to be everywhere, so let's make this into something that is more sensible. And those are some of the things that we as service providers need to take into account. Not every solution makes sense for every situation. Some are incredibly complex, and it takes an army of people to make them work, and some are very expensive, requiring licensing that makes it not even practical. It may be the bee's knees for you, but it's too expensive for your organization to afford. So there are lots of balances that you have to go through when you are choosing your solutions. And that's, among other things, that's one of the things that we're going to talk about with our biometrics here this morning. So let's get started. I have, this is almost 30 slides, I think, so I'm going to try and get through this as quickly as I can so we can have some conversation afterwards. But if you can see on the screen, I'm going to bring this, no, I'm not going to do this yet. I'm going to start with 2 little short videos, real short videos, that I pull up on YouTube to sort of give you some things to think about in reference to biometrics. Oh, and there's Ron joining us. Okay, so and I'm sure many of you have seen this. I hope you can hear it. I do have it to where it shares sound, so I hope you can hear it. But the point is, this is from the movie The Fantastics? No, The Incredibles. The Incredibles. And so let's pay a listen here.
That is what I show you, my one. That is why you are here. Edna mode. And gas.
Okay, that's number 1. You saw the keypad. You saw the hand reader. You saw the iris scanner. And you saw voice recognition. All there. Hey, Ron, good morning. And so let's go to the next one. And this is another, absolutely whimsical movie, but this is from Monsters vs. Aliens. Hand, foot, tongue, elbow, behind. Anyway, those were all biometrics. All biometrics. But when we talk biometrics, they are built into society. There is no getting around them, and they're here to stay. So I thought that because this is actually part of the I'm going to start this up so we can see it. We're doing biometrics. This is in the domain of the CompTIA Security Plus called Identity, Access, and Management. So if you are using your study guide, you'll find out how much of what I am presenting is directly listed in that study guide. In other words, there's a chance it will nearly all of it, will be on your exams. So it's good to know. It's also good to be aware of how biometrics work and why they are important for us to consider for our security solutions and what you're doing when you consider it. Okay, so here was recent news, and this is why I brought this up. This is why it came to mind for me. This is actually yesterday's Washington Post. ID.me has been in the news, and it gathers all sorts of data. It is a biometrics company, and they were contracted by the Internal Revenue Service, and the IRS was going to start requiring facial scans, i.e. selfies, for you to log into some of the IRS services. Facial recognition. And if you notice, they said, well, you know, one person, and they showed photos of him, he put on a curly wig and ended up getting accepted under multiple accounts, same photo, curly wig, not him, but got multiple accounts with ID.me or a provider that used ID.me. And according to this, it says he filed false unemployment claims of like $900,000. So it's real. It's real. So here was the big news that occurred, I think it was Tuesday. The IRS decided, after they had announced that they were going to start using ID.me, facial recognition. And then somebody basically said, do you understand what you're doing? And the IRS backed off on a program that they were about to begin. You notice it says summer of 2022. And you would have been required to provide a selfie, which could have included me looking at my camera or whatever, to get into certain IRS services. So that's why I thought it was appropriate for us to bring it up and talk about it right now. Has anybody else heard any recent news or discussion about biometrics, facial recognition, iris scanning? We'll talk about the various kinds, but anybody else heard anything recently? This was news this week. Anybody else? Good morning, Douglas.
Hi, good morning. It's not really in the news, but I think on the latest iPhones, it's required. You can't even put a passcode in it, if I'm correct. And if that's the way, like, hardware is going, I guess software is going to catch up at some point. Yeah, I don't really have anything in the news, really. Sorry.
That's all right. That's all right, because we're going to be talking about that, Ron. I've got some examples, including my iPads, so we'll discuss it. So here are some of the things that we talk about when we say biometrics. What do we mean? Could be fingerprint, could be facial recognition, retina scan, iris scanning. Those are two different things. Voice recognition, you remember Edna Mode, where she was talking into the microphone nice and slowly so that the voice scanner would catch her ID. They even have vein recognition. There have been, like in the last year, somebody came up with the discussion of, we've been doing iris recognition and retina scanning, but what they started to understand is, for example, if you turn your eye to the side, the whites of your eye are what's called the sclera. And scanners can pick up the vein pattern in your sclera, and that can be used as well because that too is unique to the individual. So we talk about vein recognition. They're referring to the veins in the whites of your eye. Good morning, Abrar. Good to have you. And then gait analysis. How you walk is a unique feature that can be used to identify you. And it's for identification and authentication. All right, so let's go back to Authentication 101. There are 3 factors in authentication. Chris, you know it. Doug, I'm sure you know it. What are the 3 factors of authentication? Anyone except Chris and Doug. 3 factors. Anyone?
Password.
Okay, password. Great. What else? Okay, that's fine. And this is important for you to know. This is standard. It has not changed. My wife, who was in the Pentagon in 2003 and 4 and 5 and 6 and 7, she was a public key engineer. She helped to design the DoD PIV card or CAC card infrastructure. And I was talking to her yesterday about what we were going to do for our slides, and I said the 3 factors, and she just pulled them off right like that. All right, so it's important for you to know these will not change, and it is most likely going to be in your Security Plus exam. There are 3 factors. 1 is what you are, 2 is what you have, and 3 is what you know. Let's give some examples. Somebody mentioned password. Well, a password isn't what you are, and a password isn't what you have. It's what you remember, okay? So that's the what you know. If you ever put your debit card or credit card or whatever into the ATM, number 1, that card is what you have, and then you enter the PIN, which is what you know. So that's 2 factors. What you have, what you know. A ATM transaction is 2 factors. A login ID and a password are both what you know. So a login and password is considered to be 1 factor. All right? So those are a couple examples. And the reference to biometrics, where do biometrics fit? Well, they are what you are. In other words, if we talk about iris recognition or voice recognition or fingerprint identification, all of those things, those are features of you. And I don't have to remember my fingerprint. All I have to do is walk up, have my finger attached, and put it onto a fingerprint reader. So that is what you are. Okay? So here's the basics. If you want to think about if somebody says, if I'm doing fingerprint reading, your finger touches a location that collects, another word is extracts, fingerprint data, which is known as features or minutia points. That will also be on your exam, or could be on your exam. So let's give some examples. Where do you put your fingers? Where do you get your fingerprints? Anybody? Okay, I'll use mine as an example. This right here on the back of my Motorola cell phone is a fingerprint reader. See the M? If I touch the right finger onto that, it reads and goes in and says, does this match something that has been placed here for getting onto this particular system? So let me show you. Da-da-da-da. I do it and it says, well, wait a minute. I only got a partial fingerprint. Uh-oh. Did I do the right finger? Did I go swimming or sit in the bathtub to where it's wrinkled or whatever? So I'll try it one more time. Nope, didn't like that, so I'll try this one. Hey, I'm in. Okay, so fingerprint reader. First of all, you notice it wasn't perfect. We'll talk about that. But you can also find it, like Ron mentioned, it's this is a classic iPad. So it's been around for years. Classic iPad. This is a fingerprint reader along with being the home button. It is a fingerprint reader. Here's an iPad Pro. My wife's iPad Pro. This little thing up here is a power button, as it goes on there, but it's also a fingerprint scanner. Now, it's quite small, so what you have to do is put your finger on it and then drag it across the fingerprint scanner. But it is still a capture method for your fingerprint. My power button on my Lenovo laptop is just like this. It's a little oblong thing that looks like a power button, but I can scan my finger across it, drag my finger across it, and it says, oh, I know you. Okay? So that's where the scanner occurs. Oh, Chris, you were going to say.
Isn't there certain machines that can take your finger, scan your finger, save it to a file, like a signature hash kind of situation, and then store it into a little chip that's on your ID card or on certain cards or certain chips? No.
You're way ahead of me. But the answer is yes, and that's why privacy advocates have been suing people who put forth biometrics because, and we'll talk about it, remember what a fingerprint is. Your fingerprint is who you are. It's not what you have, it's not what you know, it's who you are. And we'll, let's go another slide or two and then we'll talk about that. So these minutia points or these features are used at 3 various levels, and we'll talk about the different levels. One is main fingerprint features, like you've got an arch, or you've got a loop, or you've got a whorl, or whatever. You know, if you take a look at your fingerprint, you'll notice that there's, you know, certain things that go up like this, and certain things that come down like this, and then there's little arches down near the bottom, or whatever. Those are all considered to be level 1 features. Take a look at what it says here, though. Level 1 detail is not sufficient for individualization. Okay, well that's good, but it can be used for exclusion. In other words, if you put your fingerprint down and, like Chris was saying, your fingerprint image file says he's got a whorl, but it goes this way. On this fingerprint, the whorl's going this way, so it can be used for exclusion, but it can't be used for identification. Okay, so the main fingerprint features aren't used for authentication, but they are used to exclude and say, no, this doesn't match. Here we get into the second level, and this is the ridge endings, a bifurcation, a dot, etc. In other words, little itty-bitty features like where your line is, goes and stops, or a line goes and splits into 2. Or those 2 split into 2. Those sorts of things. Those are what are called level 2 features or minutia points. Okay? Then we have level 3. And these are attributes within each individual ridge. Okay? Where your pores are. If you've got a scar, these sorts of things. Those are considered to be level 3 features. Okay? This is important as you're looking at this. Sorry, I couldn't get a higher resolution point, but if you look up at the top, these are the level 1 features. You've got the loops, you've got the arch, you've got the whorls, or whatever. Level 2 features are within that particular thing where you have a line, or you've got a line that ends, you've got an eye or a hook or whatever. Those are level 2 features. Level 3 is within the lines themselves. In other words, if this one is probably the best example, if you've got pores within that line, well, level 3 sounds like the best thing to grab, right? Because it is the most detailed. Here's what your minutia points look like when they're captured. All right? You put your finger down, all of this stuff gets grabbed, and the one on the right is probably a very good example of it. They said, well, here this occurs, and then this occurs, and this is here, and this is here. So your minutia points are captured relative to your fingerprint, also relative to each other. That's why, and I'll use this as an example, that's why I can use my fingerprint like this, or like this, or like this on this scanner, and it'll work. Because it is your minutia points relative to each other. So you can, run your finger around like this. Here's the thing. Your minutia points and their orientation are both captured. All right? Both the points and their orientation in reference to each other. That allows you to do your multi-directional fingerprints. So, we talk about fingerprints being unique. You've heard that everywhere. Everybody's fingerprints are unique. I'm not falsifying that in any way, shape, or form. But the biometric process that's used to capture all of those and store all of those adds uncertainty. And this is why I'm bringing this up. Your fingerprints are on file if you've applied for a background investigation for the federal government. If you have a PIV card, remember when you got your PIV card and they issued it to you, you went to the PIV card issuance station and they said, okay, put your right index finger, put your left index finger, put your right thumb, put your left thumb, etc. And those are all in your file. And like Chris was saying, that's your file that says this is you. Okay? Anybody else you remember having your fingerprints taken for something? Well, to use the example, your fingerprint file's here.
Yes.
Reminder, good morning.
Yes. Yeah, good morning. Yes, they took my fingerprint because when I got my immigration, my green card, they took my, I think, both hands, and they took my each before I get my permanent resident.
Right. So your fingerprints, your handprint is on file. If you've ever been booked for a crime, your fingerprints are on file somewhere. And those things don't go away. That's the scary thing. Remember that file. The 3 factors of authentication. What you know, what you have, and who you are. That file is who you are. That's important to think about. Here's a little bit of trivia. The typical human fingerprint contains as many as 150 ridges. And they can all be measured and monitored and captured when you put down your fingerprint. Harminder, you raised your hand?
Yeah. So I have a question. I know according to age, these fingerprints don't change. Okay, now I am in a 40s, after 60s or 70s. So do my fingerprint is same or it is changed?
Your fingerprint is laid out. Your fingerprints are actually visible and able to be discerned even before you are born. So that's something to think about. And they generally don't change unless your skin itself changes. For example, if you have some sort of a skin condition and it changes the stuff on your finger, or you cut yourself while you're out, working on a hammer and nail, all of a sudden you now have a cut along there, but the lines and the features are laid out even before you're born. Okay? Generally speaking, they don't change. But guess what?
Okay.
Life happens and you nick your finger and you got a scar, or you get a wart or whatever. So those things do make a difference over time. And it is quite possible that your fingerprint will no longer work. I don't know if you guys watch this, but if you've got 10 fingers, almost everybody I know uses this for authentication, right?
Yes.
Did you watch what I did for my phone? I'm giving away a trade secret. Did you watch what I did for my phone? Even if somebody steals my phone and knocks me out and is standing over me holding onto my hand trying to get me to touch this sensor, it's not going to work. because I employed a very simple substitution. I use this finger. Why not?
I know that's good. Thank you. That's great.
Okay. You know, they're sitting there trying to get my finger to work, and guess what? It's not gonna. Just something simple. The various levels, level 1, 2, and 3, are based on the depth of resolution. In other words, in order to capture 2 and 3, you have to have a very high resolution fingerprint scanner. Okay? So here's some examples of levels 1, 2, and 3. Level 1, 380 dots per inch. Level 2, 500 dots per inch, which, by the way, is the FBI standard. And then level 3 requires higher resolution, like 1,000 points per inch or dots per inch. Level 3. So can anybody tell me your thoughts on what the resolution is on your phone or your iPad? How many dots per inch does your fingerprint scanner on your iPad capture? Guess. Anybody guess?
300.
300? Good guess. Anybody else?
Maybe 500.
Okay. I am looking at Wikipedia talking about iPads and MacBooks and such. It says it does 500 pixels per inch. So your iPad and phones are similar, around 500, maybe 350 or whatever, but they are certainly not 1,000 PPI. So what does that mean? For your signature file, your biometric reading that's used to unlock your phone, is it levels 1, 1 and 2, or 1, 2, and 3? Based on what we had on the slides. Remember?
1 and 2.
1 and 2. That's exactly right. Can't be 3 because the resolution isn't high enough. All right? So we're talking about all fingerprints are unique, but we're not capturing all of the minutia, even for your fingerprint scanner. We're not capturing it. It's not being captured. Okay? So let's go to the next slide. A good quality fingerprint image contains between 25 and 80 minutia points. Remember we went back, I'll pull this back up. This one, between 25 and 80 minutia points. Remember, your fingerprint is unique, but it has now said, well, I'm going to capture between 25 and 80 points on it and use those as you. Okay? So you say, is it unique all the time? Well, maybe not, because of resolution. Okay? Here's another scary point from the National Institutes of Science and Technology. All statistical models in the past 100 years only use levels 1 and 2. So anybody's biometric fingerprint reader, including DoD, only uses level 1 and level 2 details. And by the way, to go to level 3, every fingerprint scanner has to have that highest resolution, or else it won't capture it, and it can't be used to read it. So there's a cost factor in getting higher accuracy. And like it says here, nobody has used those highest quality fingerprint scanners for authentication. It's only levels 1 and 2. So here's the thing. You have a fingerprint, you put it on something, it extracts 20 to 80 level 1 and level 2 minutia points. And that is used to say this is who you are. The same thing occurs for an iris scanner, for a hand scanner, for anything like that. What they do is they take minutia points within what is observed and put them all together and say this is this person. So yes, each fingerprint is unique, but can we say that 20 to 80 points on that are unique? Maybe not. We now have a smaller data set. So here's the thing. Along with all of that, when the image file is submitted and the 20 to 80 minutia points are examined, if a high percentage of those minutia match, your identity is authenticated. You notice I said high percentage. Why is that? Anybody who's taken your Security Plus, anybody? Can you tell me? Well, a lot of it has to do with the resolution of the scanner and what your finger is like when you put it on the scanner as well. But presuming that the scanner is the highest resolution needed and that your finger is nice and clean and you put it on and it captures all of the features, there is still what's called a false acceptance rate and a false rejection rate. A false acceptance rate is where it says it's the count of incorrect or missing minutia. If you have, let's say, 80 minutia and it gets 78 of them right, it has a 2 of 80 false acceptance rate. Okay? False reject rate is where it counts all 80, but it doesn't capture all the right ones, and it says, this is not your fingerprint. And that's what happened. If you watched me when I first pulled this up and I started to scan, it said, oh, I only got a partial fingerprint. In other words, it rejected my real finger that I used. It rejected it falsely. I gave it my finger for real. It did a scan for real, and then it said, no, that's not you. That's called a false rejection rate. So there's this trade-off between a false acceptance rate, and which you want to be as low as possible. You don't want it to just accept anybody. You know, my sister walks up and puts her finger on, and it says, yep, you're Scott Ward. Well, no. You know, you don't want that. So you want as low as possible false acceptance rate. But when you get down there, you end up increasing what's called the false rejection rate. And all biometrics have this problem. There's a crossover point. That's the CER, crossover error rate. And by the way, this is in your exam. Crossover error rate means we've gotten the false acceptance rate as low as possible without raising the false reject rate too much. And that's the point where a biometric program claims that they are accurate. But are they 100% accurate? The answer is no. By design, they've got the false accept rate down to a very low number, but the false reject rate has started to rise, and that's where they stop. But there are errors. By design, errors are acceptable in biometrics. So you think about this in reference to a password. If you enter a 20-character password, how many of those characters have to be correct in order for your password to work? Hypothetical question. How many have to work? How many have to be there? Can you get it with 19 characters? You forget an uppercase instead of a lowercase? Does that work?
I think it should be 100%.
It is 100%. Your password has to be identical, not just close, in order to work. So the false acceptance rate on a password is 0. Is the same true for biometrics? No. When you scan, and you watched me do this, when you scan your finger, it says, oh, that's not you. Try it again. Chris, go ahead.
How about case sensitivity? If you turn it off, if you turn off case sensitivity, you can be one off, right?
Yes, but no password mechanism that I've seen in the last 10 years is case insensitive. And in fact, if you remember, anybody who plays with Linux or Unix, any Unix variant, it is built case sensitive. If any of you have ever used, what is it? It's not SQL. What's the other database? I forget. It's not SQL, but the other one.
Oracle.
Oracle, that's it. Oracle is built case sensitive. You can have a login. I run a Moodle system for online training, and it will not accept an uppercase in a login. You know, Christopher.Oxford, if you have a capital C and a capital O, the Moodle will say, I don't know who you are. So these systems are designed to use as many characters as they can, and that includes splitting uppercase and lowercase.
Nope, answer my question. Thank you, Scotty.
Yep. So, okay, errors are acceptable in biometrics. Scary, but true. But here's the thing. Your fingerprint is you. Remember, we said it's who you are. So if I put my, and I'm going to do this on the front of my screen, if I go like this, I have left a latent fingerprint. And somebody with the proper technique can withdraw that and make a photo of it. All right? Your latent fingerprint could be anywhere, on your keyboard, on your car door, on your keys, on the cabinet at your house or whatever. Your fingerprints are everywhere, and they identify you. All right? So what if somebody pulls this off, and it's on there, trust me, I looked and it's on there, pulls this fingerprint off and says, hi, I'm Scotty Ward, and goes to whatever I'm trying to, or whatever they're trying to get into, and falsify that it's me. All right? Latent fingerprints, which is what I just did, the oils from my finger, when I press it onto a surface, can be captured. I will give you an example that DoD wrestled with for a long time. When they were first coming out with their PKI, they told everybody to use optical scanners. Remember those little red light scanners? Optical scanners, sort of like, well, here, no. Anyway, optical scanners were those red light scanners that you put your fingers on. The problem they found is that people who were trying to beat the system could take a warm baggie with water in it, a baggie with warm water, and place it on that scanner, and the latent oils that were left by the individual who scanned last on that fingerprint scanner, some of these scanners would say, here's the image file. And remember, those minutia points don't have to be 100%. It just has to be a high enough percentage of them. So there's the possibility of error. There's the possibility of somebody faking that they're you. And one of the last things, when people first started capturing files, electronic files of images, of things like fingerprints, privacy advocates went absolutely nuts in the courts and said, that's me. In other words, if I leave, let's say I work for a bank, and they take a fingerprint for me so I can get into the vault or whatever it is, when I leave, that fingerprint must leave with me. The bank can't keep it because that's me. So these privacy advocates had a number of groundbreaking files or cases that basically said, if you leave, your image can't stay because that image is you. The electronic file that has all your minutia points is you, but you're not there anymore. So the organization, let's call it a bank, has no legal right to keep one of your factors. It's sort of like them, if any of you have ever done system admin and somebody says, what's my password? What do you answer? Have you ever done system admin? Like for a Windows system, somebody says, what's my password?
I always say that I don't have access to it. I can't see it.
You can't see it. It's built into Windows, and I'll use the Windows Security Access Manager, or SAM as it's called. The Windows SAM does not store passwords in real text.
Neither does Active Directory either.
Yeah, that's what I'm referring to, but yes.
Sorry.
Yeah, Active Directory or what's the new one, Azure. All of those use one-way comparisons, but they don't keep your password. If somebody says, what's my password, all you can do is send them a link where they can reset their password because you don't know it and you can't get it. I don't care how high up you are in the Microsoft schema admin, you can't view a password. That's how passwords are supposed to be stored. What they do is they take a hash, checksum of that particular thing, and they run it through a one-way routine, and then somebody puts in another password, they run it through the same routine and say, does the checksum match? Yes or no. If it says no, that's it. It doesn't match. But they cannot view your password. Where can you view your password? Let's say you've put in a password for a particular system. Let's say LinkedIn. Can you view the password that you put in? This is a challenge question.
I don't think so. It will show dots.
I showed this guy to you guys a long time ago, but this is a refresher. Your password is stored in your browser.
Mm-hmm.
If you go into, and you can do this later, go into Google Chrome, choose Settings, and then Passwords. It'll show every password that it holds, and it's got a little eyeball next to it. You click on the eyeball, and it says, boop, here's your password for your bank. Boop, here's your password for your 401k. Boop, here's your password for your retirement account, whatever. They're stored in your browser by default because, remember, I tell you guys this, there's always a trade-off between ease of use and security. Your browser settings by default store your passwords, and they can be retrieved in plain text. So if somebody comes and sits down at your computer, I'm sorry, go ahead.
There have been a lot of articles recently about that, especially Google Chrome and a lot of the security breaches or potential security flaws in Chrome versus some of the other browsers.
Yep.
Several of them have major problems, but certain ones are better than others in terms of personal security.
Right, right. So in reference to, thank you, Doug, very good observation. In reference to an organization, you set group policy settings that the browsers have to adhere to. In those group policy settings, for example, in our organization, it says, do not keep passwords.
Away from the organization standpoint, going at administrating your own home network, Chrome does offer you, do you want to save it or do you not want to save it?
Right.
I tell everybody that I work with or who I talk to, never, ever, ever, ever accept to save the password. That's just, to me, not secure at all.
Yep. I fully agree. So this is sort of my summary statement about biometrics. They hold tremendous promise as an authentication addition, but their inherent error rate makes biometrics unsuitable as the sole means of authentication. For now, the way to make for very secure authentication remains multi-factor authentication. What you are, what you know, what you have. Two of those three or more. But multi-factor authentication should be used. If any of you log into Google or Yahoo or Hotmail or whatever, you should set multi-factor authentication on it so that you can be secure. Otherwise, your password is all that you use, and that is what you know. One factor has the lowest security. Okay? That's why whenever I log into Google from any of my systems, my phone alerts and said, "Is that you?" Yep, that's me. That's multi-factor. It went to what I have. I have a phone along with what I know, which is my password. And it asks on the phone. Google's really good about it. It says, "Is that you? Just trying to log in on this type of system." Yep, that's me. Okay, multi-factor authentication is the way to go right now. So, my last two slides. These are quotes that I have heard from people. I have not checked the validity of them. First one, I was unable to register for the TSA Clear program at the airport. They told me that my eye scan couldn't be used because it matched someone already in the system. I heard that yesterday. And then, because I've been talking to people about today's discussion. And the next one, our satellites have such high resolution that if you turned your head to the sky, I could tell you what color your eyes are. Satellites traveling up there right now, looking down at us. So, I want you to think about this as we're talking about biometrics. Why does my friend who works at a TLA, three-letter agency, always wear these when he goes outside? Always. Always. Even in cloudy weather. Even when it's getting toward being dark. Always wears reflective sunglasses. Is he paranoid? Maybe he just likes blue reflective sunglasses. I don't think so. Something to think about. Biometrics are very helpful, but they contain inherent flaws and errors. And because of the resolution, remember those level 3 features aren't even captured. Okay? So yes, every fingerprint is unique. Yes, every iris is unique. But the process they use to capture it is not. And if they try and make it closer and closer to being perfect, it gets more and more expensive. And you have to talk to your management about doubling or tripling the cost because you want 1,000 DPI scanners so you can capture level 3 details and make sure that the wrong person isn't putting their finger on the storage bunker where all the atomic bombs are. Think about it. So, any discussion, any questions? That's what I wanted to bring up to everybody today. I hope you enjoyed this. I got a lot of fun out of researching this. I had a blast. Here's a quick little picture that shows what we're talking about. If we're talking biometrics, here's who you are, here's what the scan is, and it captures all sorts of things, puts them into some sort of alignment file that says this feature in relative to this feature, etc., and makes it into a digital file. Here's the thing, in modern day, this file is you. Your fingerprint, sure, you say I carry it with me, but where is it being stored as well? And do you trust them to make sure that nobody else is using it to say, hi, I'm Scotty Ward. Please log me into my 401k and let's take a loan. Think about it. Questions, discussion, anybody?
I'm not sure I trust any body these days. Is like there seems to be a security breach every other week somewhere.
Mm-hmm. Why do you think that is, Doug? Why? How do you think people get in?
Well, I mean, human error is a lot of it because almost every single one of them, they had some type of obvious vulnerability in their systems, and they weren't following their own security protocols, you know, and having usernames and passwords unencrypted on the same, you know, unsecured server, you know, all kinds of stuff.
Mm-hmm. I tell a war story, and I'm using this as an example. This is not the real thing, but I have a war story about when I was in the Pentagon, and the Deputy Secretary of Defense's administrative assistant, nice old lady who'd been there, looked like since the Pentagon was first built, but she had problems remembering things. So let's say this was her keyboard. Guess where her password was?
Taped to the bottom?
Taped to the bottom. So the point is, the system is only as strong as the weakest link, and you have to try and help train people so that they aren't the weakest link. And there are simple things that you can do. I gave you one example right here. Instead of using this, which everybody uses, I use this. Nobody is going to guess that. Except
I actually saw somebody use
sorry,
their
what
big
was that?
toe for
Yeah, right.
They use their big toe on their fingerprint scanner.
Uh-huh. Now, when you go in for like a federal ID card, the PIV cards or whatever, you're standing there with an authenticator person who says,
right,
put your right index finger down. And if you don't do that, there's got to be some reason like, I don't have a right index finger.
Yeah.
You know? Chris?
On the home networks, on your own home networks, it's quite easy to patch and update, and you really don't have a issue with just patching and updating. When you start working in enterprises, and I've been in many patch meetings before, what you don't want to happen is you implement a patch, and then boom, you get a group that says, my accounting software does not work at all. Mm-hmm. And you find out that the patch messed with the accounting software. And it's quite easy to sit there and say, hey, patch the vulnerability, but when you do go ahead and do the right thing, but then someone cannot be productive because you did the right thing, that's a bigger problem in the business aspect.
Yep. So to get down to the actual answer, Doug, you were right. There are two main reasons why people get into systems. Number one is lax password usage. Let me in as a password. Password 1234. Oh, but I'm going to get sneaky and make my shift to the little @ sign instead of my A. That will thwart them. Do yourself a favor and go to howsecureismypassword.net and type in any password you want. I think it's going to take you over to another place now. howsecureismypassword.net is no longer being maintained, but it will take you to a link that you can type your password in, and it doesn't capture it, but it reads it, and just says, how long would it take a computer to break into your password? and take a look at your password and see.
I'll share this because I don't use it anymore. But back when before I could do random generation of passwords, I actually used to use the Latin scientific names of fish as a base before adding my characters and numbers and things. Because I figured most people don't know Latin and most people don't study fish, so
right.
That's what I went with for my passwords.
Mm-hmm. We can talk about passwords. We don't have time this morning, but
Right.
there are numerous approaches. I have a scheme that I use, and I've used for 30 years, that is incredibly complex and yet easy to remember. How is that, you ask? Well, we can do that on a different topic, but I recommended that approach to members of the President's Commission on Critical Infrastructure Protection back in the late 1990s, and it's still no password cracker can get to it. And one last thing, I said number one was lax password usage. People get in, and number two is patching. You don't patch everything. And we talked about this many, many years ago when we started this, Chris, and you heard my wife when she walked by. We were saying, if you could change one thing, what would make that would make your organization more secure? What would you do? And people were saying, oh, I'd increase training, or I'd get, better, password mechanisms or whatever. And my wife, walking past me, heard this, and she leans back and she goes, patch everything. And she was right. If you don't patch, then your system has the possibility of having reduced security capability. And by the way, that is typically known out there. This vulnerability on this operating system, if you don't patch it, they know it's out there. And so they try known unpatched vulnerabilities almost as much as they try passwords. And your employees that are like, oh, I can't remember, or they put it on the bottom of their keyboard or whatever, you end up being unsecure as a result of training for your people. Chris.
I have a cybersecurity manager who told me that it's not the fact that you write the passwords, it's where you store them. If you store them underneath your keyboard, that's insecure. If you put them in your purse and have it in your possession and no one knows it's in your purse, he goes, that's secure. And he goes into like a very diatribe of, hey, I'm not saying don't write passwords. What I'm saying is it's where you write your passwords.
Right. Again, I can show you, and maybe this is good for a session, I can show you how to write down clues, but not your password.
Mm-hmm.
You write down clues, and so somebody gets a hold of it, and it doesn't mean a thing to them. I can show you how to do that, and we'll do that at some other point, because you can end up with incredibly strong passwords. You can make a unique password for each system, and you can have something in writing that nobody can use to make your passwords. All you have to remember is how this is associated to this. That's all you remember. But it works.
I use that actually.
Mm-hmm. Well, I think I told you about it, Doug. But yeah, it works. So if you want to learn, we'll do that on another session. Okay. Harminder.
Yeah, I have a quick question and last. I know if we are talking about password, it is a really interesting and good thing. So I have a 30 online account. It includes my bank, it includes my work, it includes my study, it includes my dental, eye, health insurance. So what I did, so the password I have everything is little bit close, similar to, sometime I am outside, sometime I am traveling. On that time, it is very hard to keep in mind what is my the class I am taking password and what is my physical doctor or eye doctor password. How I maintain this one? This is a critical thing.
Right. So you have a tendency to make one password work across multiple systems, right?
Yeah, that's what I'm doing. That's what I'm doing by example.
So I think we deserve to learn about passwords on an upcoming session. I think it'd be a lot of fun.
Thank you very much.
Yeah.
Thanks.
Any other questions before we finish up? We're all done for the day. Any other questions? Comments? Did you guys get some benefit out of this?
I want to.
Oh, definitely, yeah. I actually remember a long time ago when I was in the Honduran Army. Even though I'm not from Honduras, I have a long story. I was there in the Army. Excuse me, and I remember I spoke to an expert in dactyloscopy. He was an expert in these fingerprints, and he told me that there are some thieves that they actually, before they went into a crime or something, they sanded their fingerprints, so they get erased temporarily while they're doing their bad things, and later on they regrow, but at the moment, they don't leave any. It's like putting gloves on.
Mm-hmm.
And I think I was going to say something else, but something else. It's I spoke to a guy who sold secure boxes, and he says, like people have the means, they actually buy those lock boxes, the ones that are high with the biggest security, and they use a fingerprint.
Mm-hmm.
But basically anybody can actually use tape and some sort of, a little dust or something, and they can actually pick up that, and they use it anywhere. So it's not that.
It can leave the latent oils. That's
correct.
Right.
Mm-hmm. Yes. So yeah, it's very, very interesting, and I learned a lot today as well.
Yep. Any other comments before we finish up?
Yeah, what do you think of multi-factor biometrics?
Like you saw on those two animations at the very beginning, any two factors of, multi-factor authentication needs to be two or more of those three factors. So in other words, two passwords or two fingerprints are not multi-factor. They're both the same factor twice. So a fingerprint and another fingerprint does not make multi-factor. A fingerprint and a PIN does. A fingerprint and a password does. But a fingerprint and an eye scan does not. That's all one factor, according to the definition. So I would not say multiple biometrics would be financially feasible for your organization.
And multi-factor is better than two-factor, right?
Well, multiple means more than one. So two-factor authentication is an order of magnitude stronger than any single factor.
Got it.
And then three-factor, which I've never known an organization that does it, but both of the comical examples I gave you, they were showing, took a tongue scan, for my DNA or whatever. Those were showing, multiple factors, like three factors, a PIN, whatever. So voice recognition, again, very expensive, and I've never seen it implemented in an organization, because what you want is, let's say you're doing scanners, fingerprint scanners, you want to go from level 2 to level 3 by increasing the scanning rate of all of your devices. That's much better than a level 2 scanner, which is on most of these guys, for your organization. Rather than say, I also want an iris scanner. No, get a better fingerprint scanner. Okay.
Scotty, just one last question. It'll take long, I think. if I once had a fingerprint in my iPad device, and then I erased it, I went to settings and I deleted it, do you think it's there? It's still somewhere out there, or it got deleted completely?
That's why you need to study and learn and know about these sorts of things. Go online and ask that question. Others have. I can't say for sure. It's supposed to be a one-way thing, just like your password. Your password is not supposed to be stored somewhere, but we've seen that it is.
Mm-hmm.
So I can't say for sure. It's not supposed to be, because again, once I'm not here, nobody should be able to say, I'm Scotty Ward, and have this phone say, yep, you are. But as you've seen, it's possible.
Mm-hmm.
So, yeah.
Okay, thanks.
Sure. All right, thanks, everybody. I appreciate everybody's attendance and participation. If you have any questions or anything, find us on Facebook or our email, which is groups.io. And we will see you all next week.
Yep.
All right? Thanks, everybody.